Hi everyone, welcome you to the GATE coaching session. Myself, Veena, Department of Information Technology, ENGG.COLLEGE, working as an assistant professor. And today we are going to discuss about the operating systems. So the operating system is nothing but it is going to be a system software which is going to manage all the resources. It is going to lie in between the hardware and the software. So this system software is going to manage all the hardwares like disk such as the hard disk, mouse, and everything will be managed by this operating system. So this is going to act as an interface between the software and different parts of the computer. So the overall resources and its operations are maintained by the operating system. The controls and monitors or the execution of all other programs which is going to reside in the computer, so which includes the application program and other system software of the computer. For the example of the operating systems are Windows, Linux, Mac OS, Android, iOS, etc. So this is going to be the diagrammatic representation of what is an operating system. So the operating system is going to lie in between the application and system software, and it is going to lie in between the hardware. So this operating system is going to help for all the positioning of CPU, RAM and input-output process. So let us discuss about the thread. A thread is going to be a execution unit in the process. So each and every process, say example, when we are going to use any particular screen such as a Google sign-in screen, so it consists of different threads for its execution. So the whole thing is called as a process, and each and every process may have one or more threads. So thread is nothing but the execution unit in the process. So each and every thread consists of the components called program counter, stack, and as well as the set of registers. So these threads are not actually allowed to exist outside the process. So only inside the process the thread is allowed to execute. So a thread can be residing at any program code, or it may reside at any files. So each and every thread consists of a program counter, register, and other stack counters. So stack consists of all the intermediate informations about any particular function it is going to execute. So these are all the sample threads that we have in the process. So what is the need of thread? Why we are using the thread? So thread can share the common data without needing to communicate with each other, because it is going to reside at same address space. So the communication between the thread will become very easy. So when working with the threads, the context switching is faster. What does it mean by context switching? So context switching is whenever we are working with any particular thread, the other higher priority thread come into the execution. So that time the current execution of the thread will be stored in an intermediate program counter, and the new thread will be given CPU for its execution since it is with the higher priority. So the context switching means moving from one thread to other thread is called as a context switching. So terminating a thread requires very less time. Before terminating the process, we have to terminate the thread. So there are two types of thread, as we know. You have user level thread and kernel level thread. So user level thread is nothing but the thread which is created by the user, and kernel level thread is the thread which is created by the operating system. So whenever the user is going to create the thread, we should be careful while creating the thread, executing, and we have to terminate it. The kernel thread will be created by the operating system, and it will have the knowledge of how and which threads are executing at the current particular time. So the kernel thread does not have any awareness about the user thread. So So when we are considering the user thread, the user level thread is ignored by the operating system because it is not aware of which thread is currently executing. So user threads are simple to implement and it is done by the user. So the entire process is blocked when or if the user is going to execute the operation. So whenever the kernel level thread is going to be executed, because it is not aware of how the user is going to be executed the thread, so it will block all its execution, it will block all the user level execution, and the kernel will take over the operating system. So the user level threads are managed as a single threaded process by the kernel level thread. So threads in Java, for example, you have POSIX, and other languages are examples for user level threads. So user level threads has system calls in a separate manner, and it will be blocked by the kernel level thread because of it is not aware of which user level thread is currently executed. So it is blocked by the thread blocked, and the process is also blocked because thread is present inside the process. So the kernel, whenever the kernel starts its execution, the user level thread and the user level process is blocked and it starts the kernel level execution. So when considering the kernel level thread, the operating system is recognized by the kernel thread. Each thread and process in the kernel level thread has its own thread control block as a process control block in the system. The operating system implements the kernel level thread. The kernel is aware of all the threads and control them. Since all the kernel level threads are created by the operating system is aware of all the kernel level threads and its present execution. So it is not aware of the user level thread, as I said before, because the user level threads are created by the user and it is not known to the kernels. So the example for this is Solaris thread. So user level thread, this is an example for the user level thread. The user level thread is all present in the user space. It is not aware for the kernel level space, since kernel level threads are created at the kernel space and all the threads and the process will be managed by the kernel space. So this is the difference between the user level thread and the kernel level thread. So there are three components of thread. The first component is called start space, the second one is called register set, and the third one is called program counter. So first we are going to discuss about the register. So the registers are CPU's internal memory, which is going to offer the very speed access for any particular data and instruction. They are used for holding the data address and status information during the program execution. Basically there are 5 types of registers. So the first type of register is called as a general purpose register, which is used for storing the data and address. So the second level of register is called as a stack pointer. So the stack pointer is going to point the top of the stack in the memory. So the third one is called as a program counter. This program counter is going to hold the address of the next instruction which need to be executed. So the fourth one is called as the address register, which stores the memory address. So the fifth one is called as a data register, which is going to hold the data which is being transferred. So next is we are going to discuss about the stack. So stack is a region of a complete memory which uses the last in and first out method, because each and every data which is going to be stored at the top of the stack, and after execution the top of the stack will be popped out. So it is crucial for managing the function calls. It stores the local variables and it passes the parameters between the function. So when a function is called, its parameters and the return value are pushed onto the stack. So whenever it completes, the particular function call completes the execution, all the items which is stored will be popped out of the stack. So which will move the stack to the previous state. So next we are going to discuss about the program counter. So program counter is a register which is going to hold the address of next instruction that need to be executed from the memory space. So benefits of thread. So there are basically 6 benefits of using the threads. So first one is called enhance the system throughput. The second one is called effective use of multi-processor system. The third one is it increases the fastness of context switching. The fourth one is called responsiveness. Fifth one is communication, and the sixth one is called resource sharing. So now we are going to discuss about the questions in the particular topic called thread. So the first question is, which of the following statements about the thread is or true? First one is, threads can only be implemented in kernel space. Actually, the thread will be implemented by the kernel as well as the user. Okay, so the first option cannot be true. The second one is, each thread has its own file descriptor table for open file. Each thread doesn't have a file description. So second option is false. The next one is, all the threads belonging to the process share a common stack. Actually, each and every thread has a separate stack for its execution. So the fourth option is the correct, because thread belonging to a process are by default not protected from each other. Since all the threads is going to be used on the common space, since every process you have a place where multiple threads can be executed at any particular time. So the last option is true. So the second question is, which one or more of the following need to be saved on the context switching from one thread, say T1 of a process, to another thread called T2 of the same process? Whenever the process is going to be context switch, so the information need to be stored is the basic three components. So what are all the basic three components are? Stack pointer, program counter, and you have to store the informations in the general purpose register. So the correct option for this question is B, C and D. So let us move to the third question. So which of the following is or shared by all the threads in a process? So the options which is given is program counter, stack, address space and registers. Here the correct answer is address space, because each and every thread consists of a separate program counter, stack and register. So the only information which is used as a common is called as a address space. So the correct option is B, which is address space. Next, move on to the fourth question. Threads of a process share. So what it will basically share is, it will share the address space to store the global variables. So all the global variables of any particular process can be accessed by multiple threads. So here the options which is given is A, global variable but not heap, B, heap but not global variable, C, neither global variable or nor heap. So here the correct answer is both heap and global variables will share the process. Next, moving on to the fifth question. Let the time taken to switch between the user and kernel mode of execution be T1, and while the time taken to switch between the two processes be T2. Which of the following is true? Actually, moving from the user space to the kernel space will take more time when considering the transformation or context switching between the two processes. So the correct answer will be T1 should be greater than T2. Since T1 is the time taken between the switching between the kernel mode and user mode, and T2 is the time taken between the switching between two processes. So here the correct answer is T1 should be greater than T2. Thank you for listening the session. We will meet in the next session. Thank you all.